Good morning, students. So today we were having exam on coordination compounds. In case of coordination compounds, let's start with the question paper. So here we do observe that the first question tells us which of the following species shows synergic bonding. We know the fact that in case of synergic bonding, there should be back bonding also occurring along with the sigma bonding. That is, if you look in the given complexes, or if you talk about any kind of metal bonded with the ligand, first of all, ligand donates its lone pair to form the coordinate bond. There are certain ligands for whom metal donates back. There are some ligands for whom metal donates back. And whenever metal donates it back, that time we call it as what bonding? That time we call it as synergic bonding. That time we call it as synergic bonding. So basically, synergic bonding is nothing but pi back bonding. Here, among the given options, we have to check that which of the following among the given options can show synergic bonding or tie-back bonding. The options being number one, carbonyl. Yes, carbonyl can show, so option A will show. Option B, again it is carbonyl, that will also show. And the last option C, that is cyanide, that can also show as well. So the answer will be D, that is all of the species can have synergic bonding. Let's go for question number 2. Give the correct order of electrical conductivity of aqueous solution of the following complexes. Here we need to check the number of ions given by each and every compound. So in this question, if we follow, we know that more the number of ions, greater becomes the electrical conductivity. In case of the first compound, if you see, it is PtNH3Cl4 that gives us how many ions? 5 ions. Then comes CrNH3O6Cl3 that gives you how many ions? 4 ions. Followed by CONH3O4Cl2 that gives you how many ions? 2 ions. And the last one, A2PtCl6, that gives you how many ions? 3 ions. Henceforth, the conductivity will be ABDC. So the correct order is ABDC. So let's go for it. It goes for ABDC. Next option, next question. In the complex of FeEDTA minus, the coordination number and the oxidation number of the central metal ion. We know ADTA, EDTA is a hexadentate ligand. EDTA is what? Hexadentate ligand. So, as nothing is mentioned, we will be considering that the donating site is 6. So, how many sites it is donating from? It is donating from 6 donating sites. So, according to the oxidation state calculation, we will put Fe as x. So, x minus 4 equals to minus 1. So, x will be coming as how much? X will be coming as plus 3. So, correct answer is plus 3. So, what is the oxidation state of iron? It is plus 3. Let's go for the next question. The next question tells us that triphenyl phosphine is. So what is the nature of triphenyl phosphine? Triphenyl phosphine is our ligand, which looks like this, P at the central. Then there are 3 phenyl rings and a lone pair. So of course it is neutral in nature, and it is a monodentate ligand because the donation will occur from phosphorus, lone pair, with a pair of electrons of the phosphorus will be donated. So triphenyl phosphine is a neutral ligand, which is also monodentate in nature. So henceforth, the answer of this one is neutral ligand for sure and monodentate ligand. So option A. Next question. Which of the following compound represents minimum bond length of carbon monoxide? Here we have to understand that iron, when binds with carbon monoxide, that only responds to the synergic bonding. Just now we have discussed about the synergic bonding. What was synergic bonding? We know that ligand is donating to metal, then metal donates back to the ligand. That's what we call a synergic bonding. Now, when the metal will donate back, whenever the metal will have excess electron density, then only the metal will donate back. So I hope we understand that whenever metal is donating back to the ligand, that time metal should have excess electron density, and when it will do better donation back to the ligand, then metal ligand bond strength will increase. Metal ligand bond strength will increase. Now here the question is about metal and carbonyl, correct? When we talk of metal and carbonyl, and you are saying metal carbon bond length or bond strength, whatever, bond strength is increasing, then the bond strength of carbon oxygen should go down, of course. So henceforth, we will be studying the whole fact in two cases. Case one, metal back bonding that will lead to iron and carbon bond strength increasing, and whenever the bond strength increases, bond length decreases. If iron carbon bond strength increases and bond strength decreases, then what will happen to carbon oxygen bond strength? That bond strength will decrease because they are vice versa, and the bond length will increase. Whereas if we find poor back bonding, if we find what poor back bonding, then iron carbon bond strength will decrease and bond length will increase. And vice versa will occur for carbon and oxygen. So now come back to the question. The question asked us which will represent the minimum bond length of carbon oxygen. Just now what we understood. When the bond strength of carbon oxygen will be the highest, the bond length will be the fewest. When it will be the highest bond strength, then the bond strength between iron and carbon is less. So that is there will be minimal back bonding. So we have to find which one undergoes minimal back bonding. Minimal back bonding will be occurring for the case where the iron or the central metal atom has lowest electron density, which we can see in option C because there is a plus sign. So iron, the central metal atom, is the lowest electron density. Henceforth, it will have minimum. It will have minimum bond strength with that of carbon. As it will have minimum bond strength with carbon, carbon-oxygen bond strength will increase, bond length will decrease. So henceforth, option C will be correct. Now come for question number 6. The IUP is in of K2Cr, Cn2O2, O whole 2 NH3. It is very easy. Just we will be following the rules. And according to the rules, then it will be potassium amine, dicyanic, dioxoperoxo, chromate 6. After the test, along with the video, this PDF will be also given to you. So if you want, you can go through the PDF and get all the answers with proper explanation. Question number 7. Let's go for question number 7. Question number 7 says, which of the following pair of complex is coordination isomers? You have to understand that in case of option A, the first one is ionization isomers. Option B, it looks like they are coordination isomers, but we have to be careful that left side, PTNH3 whole 4, PTCl4, they are having total 4 NH3, 4 Cl, whereas the pair that has been given that has 5 NH3 and 3 Cl. So this is not the coordination isomers. So it gives us option C, that is COH2 whole 6 Cl3 and COH2 whole 5 Cl. This will be called to be as what isomers? Hydrate isomers. So none of them are coordination isomers. So option D is correct. None of these are coordination isomers. Question number 8. Which one of the following can show geometrical isomerism and optical isomerism both? Let's see. In case of question number 8, if we consider the compound, all the compounds, we will be observing the fact that NaC whole 3 Cl3, that is having coordination number 6, the coordinates. Geometrical isomer, optical, the compound will be CON2 whole twice and Cl2, where En is ethylene diamine, that is a bidentate ligand. You can see they can easily show cis and trans that has been drawn over here. Whenever we draw cis is optically active, so it can show dextro and levo. Why not other options? Because in case of other options, they always will be having what? They always will be having either plane of symmetry or they will be not forming geometrical isomers. Cis trans would be possible. For example, option C. Option C is also optically active, but it won't be able to show geometrical isomers. So henceforth, correct answer is option B, CON whole twice Cl2. Which of the following complexes can exist as enantiomers? Just now we have learned that whoever will be optically active, they can act as isomers. Among all the options given, we do find that everyone other than option D, everyone other than option D can have cis trans or may have certain arrangement that they are having plane of symmetry. So option D, that is COEN whole twice. Let me show you how. Is COEN whole twice. So this is optically active, and henceforth this can show you optical isomerism. This something like this. I hope we are clear with this. Next, question number 10. Which of the following pairs of species the number of unpaired electrons are same? Students, in this question, we have to calculate the number of unpaired electron according to CFT. If you follow the rules of strong field ligand and weak field ligand, you'll observe that first case, Fe6, F is in 3 plus, so it will have D5. So it will be one unpaired electron because it is all of them will get paired. FeCN6 4 minus, it will be D6, so 0 unpaired electron. COF6 will give you how many unpaired electron? Again D6, so 4 unpaired electron because F is a weak field ligand. H2O6, water acts as a weak field ligand, so it will also give you 4 unpaired electron. So all over this complexes gives us 1044. So according to the question, which of the following pairs of the species the number of unpaired electrons are same will be observed for option number 3, that is COF6 and ApH2O6 2 plus. Question number 11, find out the correct order of stability. Now here, whenever we talk of order of stability, we have to understand that according to spectrochemical series, the ligand has some strength order. That is cyanide, which is more powerful than NH3 and it is more powerful than water. The strength of the ligand is directly proportional to the stability of the complex. Better the strength of the ligand, more will be the stability of the complex. One more thing also comes into the fact that chelate rings. I think we have heard about chelation. More the number of chelation, better becomes the stability. So in case of the first one, according to the ligand field strength, who will be the highest? CN, CrCN6 3 minus. So that shows the highest, followed by NEC and followed by H2. In case of chelation, more the number of ethylene diamine, more becomes the stability. So again, CrEn whole twice, followed by En whole twice and En. And the last one, the central metal atom depends on the hydration because water is the aqua or water, whatever ligand we say, that is being denoted or that is being held by the positive charge density of the central atom. Henceforth, the first one, 3 plus, will be more than 2 plus. So according to the orders which we studied, we understand that all of them has been given the correct order, so answer is all of them. Question number 12, which of the following pair differ in geometry and resemble in magnetic behavior? So the geometry will be different, and as you see, all of them are mostly having coordination number 4, 5, 6. The coordination number 4 can show you two different geometries. That is square planar and tetrahedral. Coordination number 6 only shows you octahedral. Coordination number 5 also can show you trigonal, bicameral, and square pyramidal. Let's go for option number 8, question number 12, option number 8, NiCO4, which is neutral, NiCN4, 2 minus, Ni2 plus. When it is neutral and when it is 2 plus, the oxidation state of nickel will be changed. So there will be two unpaired electrons for NiCO4, which will show paramagnetic nature, whereas for NiCN4, it will have again what nature? NiCN4 2 minus. So the lower electrons, all of them will be paired, whereas upper two electrons will be still unpaired. So henceforth, this will be also of paramagnetic nature. The first is NiCO4 is tetrahedral in nature, while NiCN4 is square planar in nature. That is, the answer will become like this. Let me help you with it. When you destroy d orbital for nickel will be given a management like this. In case of NiCO whole 4 and in case of NiCN whole 4. Here it will show you what? It will show you tetrahedral. Here it will show square planar. So magnetic characteristic remains same, but overall this changes. What changes? Overall the arrangement changes. Two unpaired electrons showing paramagnetic characteristics for both the cases. The first one is showing tetrahedral structure, whereas second one is showing square planar structure. Let's go for next question number. Which of the following color frequencies are absorbed by activated Ni2 plus ion? Now this we can directly study from NCERT. This is a direct question from NCERT. We know that Ni2 plus shows green color and henceforth according to the color wheel, the complementary red color is being absorbed. Next question, question number 14. Which of the intercomplex CONH0 is represents the species acting as Lewis acid and Lewis bases are, of course, the central atom acts as a Lewis acid and ligand acts as a Lewis base. Question number 15. Select the odd one with respect to EAN. EAN is effective atomic number. I think we all know the formula. Effective atomic number formula states that atomic number of the central atom minus the oxidation number. Atomic number of the central atom minus the oxidation number plus 2 into coordination number. That gives you EAN. You have to calculate the EN for all of them. You have to find out which one is not matching. And hence, that will be the answer. In this question number 15, you will find option 2 is having 33, whereas all of them are having EN exactly equal to krypton, that is 36. Question number 16, they are asking that which of the following is incorrect IUPAC. So we find that the incorrect IUPAC in this question is H2OCl5N. If we do not mention an oxidation state of OS is not given properly, so answer is H2OS, the osmium Cl5N. Question number 17. The isomer which has been given, that isomer is what? Of course, that is trans isomer. Question number 18. Here there will be a change. The three arrangement shown for the complex this, which one is the correct statement it will be. If you see that from the beginning of the question only, that name of the complex is given, COEN and AC whole twice, BR2 twice plus. So option number 2 that has been drawn, that is not only correct. So henceforth we have to compare only 1 and 3. And as soon as you see 1 and 3, you can easily understand that 1 and 3 are what type of isomers? Optical isomers. Question number 19. Green color NiPH2 E2 EgO2 Br2 has magnetic moment of 2.82 Br. The geometry and the number of isomers are possible of the complex. In case of question number 19, we find that what is the magnetic moment? It is 2.83 Bohr magneton, and it has two unpaired electrons. Both of the Br minus and PPH2 are weak field ligands that forces nickel to have what geometry? Tetrahedral geometry. Henceforth, no isomer becomes possible, neither geometrical nor optical. Therefore, two ligands are same, and since there is two ligands same, and there can be a plane of symmetry present. That's why we understand the fact that overall, the number of isomers possible for this complex, that the complex that has been given to us is of tetrahedral geometry. So both are not possible. So that is 0, and number of unpaired electrons is 2. So henceforth, we will be opting for the option B, tetrahedral and 2. Tetrahedral and 0. Sorry, option D is correct answer. Question number 20. Which of the following planar complex is diamagnetic and shows stereoisomers? So we have to draw all the complexes, and we have to find first of all the oxidation state. When you find the oxidation state, you will find that nickel is having the oxidation state of +2, platinum is having the oxidation state of +2, cobalt is having the oxidation state of +3 for both the cases. And according to that, we have to find out, looking into the ligand and everything, what will be the geometry, where we will find that NH3 is a strong NH3 being with platinum will give you square planar geometry, whereas chlorine being a weak field ligand and water being also a moderate field ligand will give you in +2 oxidation state cobalt to be +2 geometry. So let me show you how it will work. This is a question. Question is, which of the following planar complex is diamagnetic, shows isomerism? We will do the correct option if we go for COEN whole twice. COEN whole twice. So or this has been 3 plus. So in case of cobalt, the electron distribution is like this. It is 1, 2, 3, 4, 5, 6, 1, 2. In case of cobalt, we will observe that 3 plus means it is D6. So the electron distribution will be like this. After the electron distribution comes like this. En is what type of ligand? En is moderate type of ligand. But here, cobalt being in +3 oxidation state will show the electron distribution like this. Once the electron distribution is done for cobalt, what we will observe? We will observe the whole compound. We will observe the whole compound to be having what type of geometry also already we have drawn it once. Something like this will be formed, and it is optically active. So the question is, which of them shows stereoisomerism? Definitely COE and voltage can show stereoisomerism. These diameter, so answer will be option D. Next question, how many total number of isomers are possible for the complex CrSCN2 is equal to 4 plus 4 plus. So in this case, CrSCN2 and NaCl4 plus can show both geometrical isomerism and linkage isomerism. So as it can show both geometrical and linkage isomerism, so for everyone, there will be 3 isomers. That is, both cis and trans will be possible. And cis can show both D and L. So if you see the solve, Sc and SCN, both linkage side is sulfur. Both linkage side is what? Sulfur. And they can have cis and trans both arrangement. So cis have D and L, so 3 will come here. In case of the second one, NCs, NCs. Here also cis will have both D and L, so 3 will come here. And the last is NCs and SCN. It can be also with cis and trans, so to both D and L. So total 9 isomers will be possible. Question number, next question. 21. How 22. How each of the following is optically active? Now here, you can easily understand this in this question. Platinum is arranged with 4 different ligands, so not one can give you plane of symmetry. We have already seen COE and voltage. You can draw and see it also can't give you any plane of symmetry. Neither do glycine can. Finally, zinc is having all 4 ligands different. It can not have any plane of symmetry. So all 4 of them are optically active. So answer is 4. We see the total number of donor atoms in EDTA. We all know EDTA has how many donor atoms? 6. So the donor membrane size will be 6. 24. An octet complex with formula COCl2NOH reaction with excess of ATP gives 2 moles of H. Considering the oxidation state to be X, the value of X plus N is. In this case, the value of X plus N will be coming how much? Let's see. It's easy question out here. For the complexes CONH3 and NH3Cl. 5 NH3 is required so that the oxidation state becomes +3. So overall, the X plus value N value will be 5 equals to 8. Let's go for next question. The next question says the spin only magnetic moment value of square planar complex is dash Pm. So in this case, we find that the spin only magnetic moment of square planar complex is dash Pm. So we have to find the oxidation state first. We need to understand that fluorine is only the one who is having anionic ligand. Others are neutral. So oxidation state of platinum will be +2. The oxidation state of platinum will be +2. We can easily understand that from 78. What will be the arrangement between the DSP and platinum being 78 is even number, 2 electron bond. So it will be an even number of electrons, so everything will be paired. And as everything will be paired, there won't be any unpaired electrons, so answer will be 0. There won't be any magnetic moment. Next question number 26. The conductivity of solution for complex formula corresponds to 1 electron electrolyte, the primary valence of the center. We need to understand that in this case, 2 Cl will be inside and 1 Cl will be outside. That is the overall complex will be looking like ACl and Cl. But we know that no matter what, if there is Cl inside or outside, if it is helping in the oxidation state of the central atom, it will have its position as a primary valence. So 3Cl means primary valence will be +3. Next question. A transition metal MnCrCu and Fe has the highest electrical potential. It forms a metal complex with the type of this, the number of electrons present in the Eg orbital of the complex. So we have to know that who shows the highest electron potential. Among them, cobalt shows the highest electron potential, maximum positive. So henceforth, cobalt we will consider cobalt will show only 1 electron present in the Eg orbital. Next question. We have to consider all these complexes, and there is a tricky question. They're asking which one has the yellow color. Now be very careful which one has the yellow color. Because we have to use our concept of CFT and understand that all the ligands given are strong field ligands. All the ligands given are what? Strong field ligands. As all of them are strong field ligands, everyone will show yellow. Everyone will absorb violet color. As everyone will absorb violet color, what color they will show? They will show yellow color. Then they will be showing yellow color. We just need to find out who is paramagnetic in nature, because if you see cobalt 3 plus diamagnetic, Fe4 plus diamagnetic, Fe3 plus, of course, it will be paramagnetic. Fe2 plus again diamagnetic, Fe2 plus again diamagnetic. So only one is there who will be showing us paramagnetic nature, that is K3CN6. And henceforth, we have to take its magnetic moment that will be coming as 1.73, because Fe3 plus means how many unpaired electrons will be there. Fe3 plus means the number of unpaired electrons will be 1. So root over 1 into 1 plus 2 will give you 2. 1.73 nearest is 2. So answer is 2 for question number 28. For the reaction given below, the two equivalents of HCl precipitated out and the value of X will be. Guys, we know very well Cl should be outside of the coordination sphere, in the ionization sphere it should be there. Then only the precipitate will occur. So we need at least 4 NH3 to make 2 Cl go out, 5 NH3 to get a Cl out of it. So on case of 29 answer will be 5. Let's go for the next. In this question, they were asking us to draw the most stable ones. We have to understand that in case of CuEn voltage SCN, we always will have 3 combination, both ligands SC and SCN, ligand NCS, NCS, and one NCS and SC. Theoretical 3 combinations possible. Each one will have cis and trans. In case of chelating complexes, cis ones are observed to be more stable than the trans ones, and henceforth, relatively more stable isomers is found to be how many? 3. Let's go for next question. 31. Among the following species, the hybridization states are. We just need to see the compound, draw down the according to our theory, valence bond theory. We need to draw out what will be their hybridizations. It will be found that the hybridization of NiCO4 is sp3, NiCN4 is tsp2, and NiCl4 is sp3 again, because Cl is a big field. Next question. Among the following ions, which is that outer orbital complex. So we have to understand that outer orbital complex has been the complex which will be using outer d orbital, since all of them are what? Since all of them are coordination number 6 octahedral. So we have to draw down all the compounds. We have to find out which are weak field ligand, which is strong field ligand, and after we do that, we can come to know which are outer orbital complex and which are inner orbital complex. Among all of them, we will find only one is having Cn, that will definitely make it inner orbital complex. Other than that, all of them will be giving us what? Outer orbital complex. So answer is 2, 3, and 4. And next is given as oneness theory. According to oneness theory, the diagram has been drawn. They are asking us to find out the correct statement. Here, we know the fact that in this statement, there is one Cl acting as primary valency. So therefore, only one will be only giving 1 mole of precipitate, because other 2 Cl are giving us what? Primary, secondary both. So henceforth, only 1 mole of HCl precipitate occurs when you react with HCl. So option C is correct. There are which of the following statement is not correct. In this case, FeNH3CSO4 will give you Fe2 plus, where NH3 is a strong field ligand. If all electron is paired, then it will be what in nature? It will be diamagnetic in nature. What in nature? It will be diamagnetic in nature. Question number 35. So yeah, in this question, we have to understand the theory behind this question. We have to immediately go for the ligand field strength. Stronger the ligand, better the splitting, higher the wavelength absorbed. So henceforth, we will see that as the metal ion is fixed, the increasing field strength of the ligand among the spectrochemical series varies in the order. NO2 minus is the highest, followed by NH3 and H2. So henceforth, more the splitting, lower wavelength will be absorbed. If the splitting E equals to Hc by lambda, we know that. If the splitting is the order NO2 minus NH3 and H2, the complex absorbing the wavelength will be in the order H2 will be the highest, then NH3, then NO2. In this case, they are asking us to find out the incorrect IUPAC of the compound. There is a one printing mistake. There should be BF4 minus. I think all of you know this. Then henceforth, the tetrafluid borate ion is the wrong. It's the correct one. Second one is also correct. Last one, the third one is the wrong, and D is none of this. Option C is correct. This is the wrong way. 37. Okay, question number 37. PC. Select the true statement of the following for the metal carbonyls. 5 bonding strengthens metal carbon bond order as well as CO bond order. 5 bonding weakens the MC bond order as well as CO bond order. 5 bonding weakens the MC bond order but strengthens the CO bond order. Okay. So just now we have discussed in the first question that more will be the bond strength between carbon and metal. Equal will be the bond strength between carbon and oxygen. So henceforth, the correct answer is 5 bonding strength is metal carbon bond order and weakens the CO bond order. Next question, question number 39, they're asking the number of unpaired electrons. So basically, we have to find out the ligand strength, then we have to find out the oxidation state and calculate the number of unpaired electrons according to CFT, crystal field theory. This is the correct way to calculate. You have to calculate through CFT. Next one remains the same. We have to find out the correct match of the given matrix. Here we have to use the idea of all the options A, B, C, D. We have to go same pattern. We have to calculate the oxidation state. We have to calculate the number of unpaired electrons. Then you have to match with column 2 and column 3 according to our VBT valence bond theory as well as crystal field theory to find out which is the correct matrix. Answer of this one will be coming as option C, that is VPY. V is NiCO4, which is neutral, so overall it won't be having any magnetic moment. And then last is will be coming P3. So next, in this case, statement they are saying that if it is using this white precipitate when reacts with AgNO3. Statement 2 says chloride ion in the complex is non-ionizer. We have to understand that whenever K2PTCase is forming, no cell is outside the coordination sphere. It can't be one precipitate. So statement 1 is wrong. Chloride ion in the complex is non-ionizer. That is correct because all of them are what? All of them inside the coordination sphere. So statement 2 is 1 is false and statement 2 is correct. So the question number 40, correct answer is D. So this is all. I will be sharing the PDF as well with this. Thank you and all this is for next results. Yes, sir. Yeah,